the regression output as displayed. The first one you have here, box a table here, is a variable enter / removed. Not too very much important for us here. So we are going to now go to model summary, which is very important. This table is very important because of the arrow square here. Arrow square tells us the extent or the variation, explanatory extent to which our outcome variable is explained by the predictor variable, which the study has. Then, for the ANOVA table, it's very important because it tells us the extent to which the overall model of the linear regression is statistically significant. So you have to check this significant level here. If it's less than 0.05, means the model as a whole, that is overall, is statistically significant. So take note. Here it is less than 0.05. It is 0.001, which means it is strongly statistically significant. Take note of the F statistics here, which is 1403.110. We are going to use it in our report. Take note of the residual row here, 98, which is very important. We are going to use it. And then take note of your degree of freedom here, 1. On the regression row, which is very important, we are going to use it. Then you can see your dependent variable test score is showing here. And then B, predictor study has. Then go to the coefficient table. Under the coefficient table here, you will notice that we have unstandardized coefficients, B, and we also have here standardized coefficients, beta. Now, because we have only one variable here as independent variable, which is study as, we are going to report unstandardized B. That is the row here, which is 9.937. Take note, if you include more than one independent variable in this model, and if we are interested in comparison between the independent variables, then we will have used this standardized coefficient beta. But for this practical purpose, which we are doing, it's not for projection, it's for practical purpose, and it's only one independent variable. It's not a multiple linear regression. If it's multiple linear, we'll have used standardized coefficients. I'm emphasizing it once again. But because it's just one independent variable, we are using study as, so that when you are using only one dependent variable and you are not interested in comparison, and it's not a multi-level linear regression, so you use unstandardized coefficient B. But if it is multi-level linear regression with many variables, for comparison purpose, you use standardized coefficient beta. This line here, which is 0.967. So take note of this also statistical significant level here. This is the level that informs you if a particular variable, the independent variable, is statistically significant. If it's less than 0.05, it tells you that it is statistically significant. Here it is less than 0.001, which means it is strongly statistically significant, meaning that study has statistically significantly influenced or is associated with test score. Why this significant level is for individual independent variable enter. The 1 year on this ANOVA is for overall. Now for the coefficient for the 95% confidence interval, you have the lower bound here and the upper bound. So how do we present this in our thesis or dissertation or manuscripts? Let's divide this into two so that you can see example on how you can present it. Divide the table, the screen into two. That will be easier for us to present. And then we can now bring in example here how to present it. So now let's look at this. You see, this is example of regression interpretation for thesis or manuscripts. You can start it with this by saying a simple linear regression was conducted to examine the effect of study hours on student test scores. The results indicated that the model was statistically significant because we know it says it was statistically significant here. F36, which is the F36 here, bracket open 1, which is degree of freedom 1 here, comma 98, which is a residual rule here 98, bracket close, equals to 1403, which is this F36 here, 0.11. P-value less than 0.01, which is p-value less than 0.01. It's important for us to take note that if we put here less than 0.05, it is also correct. And explain approximately 93.5% of the variance in test score. That 93.5%, we are referring to the R square here. 0.935. That is, if you convert to percentage, you are going to have 93.5% of the variant test score. The regression coefficient for study hours was beta. I've told you why we are using this B here, because it's only one dependent variable we included. Equals to 9.94, p-value less than 0.01. Look at it here. Let's go down to coefficient B here. Study hours 9.937 approximation, 9.94. P-value here, which is our p-value significant here, 0.01, suggesting that for each additional hour spent studying, a student test score increased by approximately 9.94 points. Meaning the more a student study, the more the student is likely to score or perform better in test score. The 95% confidence interval for the effects range from 9.41 to 10.46. These are confidence interval here. You see, bring it down. So the down one is what we had, 9.411 to 10.464, indicating a precise and reliable estimate. These findings suggest a strong and positive relationship between study time and academic performance. You have just learned how to run and interpret a linear regression analysis in SPSS. If this video helps you, please like, subscribe, share this video with classmates, colleagues, researchers. Comment below with your comments and questions. I'll respond to it. Stay connected with Micro Solutions for more easy to follow research and statistics, lectures and tutorials. Thanks for watching and see you in the next video.